In this video, we want to graph the function 3 to the x minus 9. We want to find any zeros of the function g. And then based on the graph that we get, we want to solve for g of x greater than 0. So let's start off with the graph. Now the graph of the exponential g of x equal 3 to the x without the minus 9 will simply be a graph that passes to the point 0, 1 and rises. It approaches the x-axis and it goes off like this. And typically the graph of any function with base b, in this case 3, greater than 1 will be an increasing function, rising this way. If the base, this would say 1 over 3 or 1/3 to the x power, then it would be going down, decreasing. Now putting a minus 9 there simply moves the graph up or down. If this is a positive 9, it moves it up 9. In this case it's minus, so it goes down 9 units. So here's your horizontal asymptote for this one. The graph approaches the line, the x-axis, in this case y equals 0, and then it rises this way. Before we continue with the graph, let's just look at how do we find the zeros for this. So we want to know whether is this 3 to the x minus 9 equal to 0. So let's just set that equal to 0. 3 to the x minus 9 is equal to 0. And it's basically solving a exponential equation. So I bring this over this way. Add 9 to both sides, we get this. And then we can write the 9 as 3 squared. So I got a base of 3 here, a base of 3 here, so x has to be 2. So this then tells me 2 then would be a 0. So that would tell me that the graph has an x-intercept at the point 2, 0. So the graph of this would look like this. It's this same graph here that I have here, except you move it down 9 units because of the negative 9. So instead of having a horizontal asymptote at y equals 0, you have it at y equal negative 9. So let's suppose this is a horizontal line, y equal to negative 9, which would be, of course, the asymptote. Instead of y equals 0, it's negative 9. And it's going to pass to the point x-intercept at 2, 0. So I'm going to go over 2, 0 this way. And the graph is going to go like this. So that would be the graph. That's the first part here, the graph. And then to find the zeros, we did it already. In this case, we only have 1 0, that's 2. In other words, a 0 simply means here you place the x by that value, in this case 2. 3 squared is 9, minus 9 is 0, so you get 0. And of course, based on what we just did, the 0 also corresponds to the x-intercept. So the answer to part 2, find the zeros, we only have 1 in this case, and that's 2. And then based on the graph, we want to solve this inequality. So for what values of x is g of x positive? Well, just look at your graph. You can see right here, this is 2, which corresponds to the x-intercept, or one of the zeros. To the right of that, the graph is above the x-axis, so that's positive, greater than 0. And then to the left, for whatever value is less than 2, the graph is below the x-axis. That's a negative. So the solution for this one then, solution to the inequality, then would be in interval notation, it would be every number greater than 2. So in interval notation, it'd be 2 to infinity. In set builder notation, be the set of all x, such that x is greater than 2. So we have the graph here, and again a y horizontal asymptote in this case would be y equal to -9 instead of y equals 0. The zeros of this is 2, and the solution to the inequality g of x greater than 0 is the set of all x larger than 2. So we can give it in interval notation or set builder notation. Thanks for watching. We'll see you next time.